Numbers that make your head spin. For 0.5 trillion cubic meters of rock, 10 trillion tons of weight. A depth of 1,857 meters, a length of 446 kilometers. Terraces, as if cut with a ruler, with right angles. Horizontal platforms extending half a kilometer wide. Stable support pillars standing amidst the cliffs. The official stance. All of this is the work of a river 100 meters wide, working over millions of years. A river that, over 155 years of continuous observation, hasn't changed the canyon's outline by a single millimeter. Copper, uranium, quartz, limestone, everything lies in neat layers, perfectly suited for sequential extraction. An engineering feat attributed to the elements. But to figure out who really carved the largest quarry on Earth and where trillions of tons of rock disappeared to, we have to start from the beginning. From the moment an engineer first looks at the Grand Canyon from a bird's-eye view. Before us is the Grand Canyon, Arizona, southwest United States, one of the most famous natural landmarks on the planet. An engineer's view, dimensions, and volumes. Millions of travelers come here every year to stand on the edge, take pictures, and go home feeling they've touched a natural wonder. But today, I suggest looking at this object not through the eyes of a tourist, but through the eyes of an engineer. Calmly, armed with a pencil and a calculator. Let's start with the dimensions. The length of the Grand Canyon is 446 kilometers. To feel the scale, that's the distance from Moscow to Nizhny Novgorod. The maximum width is 29 kilometers. This is not a ravine, this is the size of a medium city. The depth reaches 1,857 meters. Stack 6 Eiffel Towers on top of each other. And the tip of the last one will barely peek over the edge. Now let's calculate the volume. We'll take the average cross-section of the canyon, simplifying it to a trapezoid. With bases of about 15.5 kilometers and a height of 1.5 kilometers. The cross-sectional area is about 15 square kilometers. We multiply by the length of 446 kilometers and get about 4.4 to 4.5 trillion cubic meters of rock. At an average density of limestone and sandstone from 2.4 to 2.7 tons per cubic meter. That's from 10 to 12 trillion tons. 12 trillion tons of rock that was once here and has now disappeared. Ask yourself one question. Where did it go? Where did trillions of tons disappear to? Official geology points to the Colorado River, a small waterway with an average flow of about 600 cubic meters per second, with a channel width of 60 to 100 meters and a depth of 3 to 5 meters. This river, which in some places can be crossed by wading, supposedly cut a chasm almost 2 kilometers deep and 30 kilometers wide. Evaluate the proportion. River width is 100 meters. Canyon width is 29,000 meters. A ratio of 1 to 290. It's like claiming a garden hose washed out a foundation pit for a skyscraper. Anyone who has worked in quarries or seen industrial excavations with their own eyes will instantly recognize a familiar picture. Look at the profile of the Grand Canyon. In the cross-section, you won't see a smooth V-shaped profile that water leaves. Water always leaves behind rounded, smooth forms. Look at any river gorge, at slot canyons like Antelope. There, everything is smooth, streamlined, not a single right angle. But here we have clear horizontal terraces every 50 to 200 meters vertically. Flat, table-like peaks with areas of square kilometers. Right angles of walls in certain sections. A tiered structure, where each tier corresponds to a separate geological layer. And now open in a neighboring tab a satellite image of the Mir Diamond Quarry in Yakutia or the Bingham Canyon Copper Quarry in Utah. It, by the way, is located just 120 kilometers from the Grand Canyon. The depth of Bingham Canyon is 1,200 meters. Diameter is 4.4 kilometers. Put the pictures side by side. The same step terraces, the same horizontal platforms called berms. The same vertical cliffs between tiers, the same supporting pillars left inside the excavation for wall stability. The only difference is the scale. Turn on the logic of an engineer, not a tourist. Water does not cut step terraces with right angles. Water does not leave horizontal platforms half a kilometer wide. Water does not create flat table peaks with a perfectly even surface. All of this points to signs of purposeful, layered, industrial mining. Before you is not a natural wonder. Before you is inconceivable engineering on a planetary scale. An exhausted industrial site, the size of which exceeds everything modern civilization can even imagine. Impossible engineering or nature. Let's analyze the official version, without emotion, without prejudice, strictly scientifically. Modern geology claims the following. The Colorado River over 5 to 6 million years gradually washed out the canyon. The mechanism is simple. The plateau slowly rose due to tectonics, and the river cut deeper into the rock. A beautiful, elegant theory. Now let's see what the rock is made of, which this river supposedly washed away. At the very bottom lie the Vishnu schists, metamorphic rock 1.7 billion years old. Hardness on the Mohs scale, from 6 to 7. For reference, a hardness of 7 is quartz, which cuts glass. Above lies Tapete sandstone, then Bright Angel shale, then Mauve limestone. Then comes Redwall limestone. And here we should pause. The thickness of this layer reaches 240 meters. 240 meters of solid carbonate massif. Above is the Supai group, then Hermit shale. And here is another fundamental layer, the Coconino sandstone. It is practically pure quartz, silicon dioxide. Hardness is 7 on the Mohs scale. Quartz sandstone is an abrasive material. It is used to polish metals, process granite, and sharpen cutting tools. Any mining engineer will confirm. Quartz sandstone is not river silt or clay. Water with suspended particles cannot effectively destroy a material that itself is an abrasive. It's like trying to grind down sandpaper with a wet rag. Anyone who has worked with hydraulic soil washing on a construction site knows. Water perfectly washes away soft loams, sandy loams, loose sediments. But it is powerless against quartz sandstone, let alone against metamorphic gneiss with a hardness of 6 to 7. Now let's calculate the erosion rate. Official version, a depth of 1,857 meters in 5 million years. That is 0.37 millimeters per year, 1/3 of a millimeter. The thickness of a sheet of paper in 3 years. Over 155 years of continuous observations since John Wesley Powell's first expedition in 1869. The canyon should have deepened by exactly 57 millimeters. That is less than 6 centimeters. A value that is physically impossible to record against the background of natural fluctuations of the bottom level. If you put Powell's expedition photos next to modern images of the same spots, you won't find a single difference. Over a century and a half, not a single visible wall collapse, not a single measurable deepening of the channel. The process supposedly happens right now, but it's invisible, immeasurable, and untestable. Convenient, isn't it? But speed isn't the main problem. The main problem is logistics. Where did over 4 trillion cubic meters of rock go? The official answer, the river carried it all into its delta, into the Gulf of California. But the volume of the Colorado River Delta is only a tiny fraction of what should have ended up there. Let's translate into understandable numbers. If the river carried rock evenly over 5 million years, every second it would have to transport about 25 cubic meters of solid soil. 25 cubic meters a second is one fully loaded dump truck every 2 seconds. Round the clock, without days off, for 5 million years straight. With an average water flow of 600 cubic meters per second, this means that 4% of the flow wasn't water, but rock. Do you really believe in this version? Logistical question number 2. Why doesn't the canyon expand exponentially towards its exit? Think like a hydraulic engineer. The river flows, collects tributaries, gains volume and energy. Logic dictates the canyon should have the shape of a funnel, narrow at the top and widening downstream. But instead we observe relatively straight walls for hundreds of kilometers. This is not the behavior of a river. This is the behavior of a mechanism working with constant productivity. Question number 3, and it is perhaps the most inconvenient for official geology. The Grand Canyon has over 600 side canyons branching off perpendicular to the main channel. They have the exact same stepped structure, horizontal terraces, vertical walls. But in these side canyons, there are no rivers. Many of them are absolutely dry. Ask yourself a question, what washed them out? The official answer, rain erosion over millions of years. But rain doesn't carve 500-meter vertical walls with horizontal terraces. Rain creates gentle slopes, washes soil over an area, forms ravines with a V-shaped profile. Here we have perfect U-shaped cross-sections without a single river. And finally, the economic scale. To accept the official version, we must believe that the modest Colorado River did work, greatly exceeding the total extraction of all open-pit mines of humanity. For the entire history of mining, all the quarries on the planet over all time have extracted about 50 to 80 billion cubic meters of rock. The Grand Canyon is 4.4 trillion, a difference of 50 to 100 times. One river did more than all humanity with all the equipment of the 21st century. This is impossible engineering attributed to nature. Now let's conduct what in forensics is called a crime scene inspection. Only instead of a magnifying glass and gloves, we'll take engineering knowledge, mining experience, and elementary logic. Let's start with the geometry of the excavation. The profile of the Grand Canyon has a pronounced stepped structure. Clear horizontal terraces alternate with vertical walls every 50 to 200 meters. Each such terrace exactly corresponds to the boundary between two geological layers. This is no coincidence. In an industrial quarry, steps, they are called berms, are made exactly like this. Different rocks require different slope angles, different excavation equipment, different transport. So a horizontal platform is left at the boundary of the layers. Now look at the width of these platforms in the Grand Canyon, from 50 to 500 meters. 500 meters is half a kilometer of flat horizontal surface. Ask yourself, why would nature create this? But in a quarry, such a platform is a working level. Transport moves along it, dump trucks, conveyors. Separately, it is worth mentioning the flat peaks, the so-called table mountains or mesas. Any open-pit mining specialist will tell you, these are working levels of a quarry with pillars left for wall stability. A pillar is a column or mass of rock that is intentionally not removed so the walls don't collapse. The table mountains of the Grand Canyon are precisely these pillars. They stand as even columns amidst the excavation. From the point of view of materials science, the Grand Canyon is not just a hole in the ground. It is a cross-section through a rich mineral zone with a clear layered arrangement of valuable resources. Vishnu schists at the bottom contain quartz, mica, garnet, and potentially rare earth elements. Redwall limestone, a quarter of a kilometer of almost pure calcium carbonate, a primary building material. If an antediluvian civilization used geopolymer concrete, limestone would be the #1 raw material. Coconino sandstone, almost pure silicon dioxide. High-quality quartz sand is the basis for glass and abrasives. And here is what is especially remarkable. Numerous copper deposits are located right on the territory of the canyon. The Orphan Mine is located right on the edge of the canyon. It mined copper and uranium until 1969. Copper, uranium, asbestos, silver. All this is officially present in the rocks of the Grand Canyon. This is data from the U.S. Geological Survey. A quarry is placed where there is something to mine. Now about the traces of processing. Look at the walls. Vertical planes with horizontal steps, right angles. This form is absolutely atypical for water erosion. Water creates rounded, smooth forms. Pay attention to the side canyons. Many of them are absolutely straight for tens of kilometers. Water does not flow in a straight line. It always meanders, seeks the path of least resistance. A straight canyon 40 kilometers long is not a riverbed. It's a trace of directional excavation along or vein. In some sections, traces similar to thermal exposure are visible. The rock changed color to black. If an antediluvian civilization used thermal methods to weaken hard rock, such traces would be there. Now about what lies at the bottom. At the bottom are thick deposits of clastic material hiding the lower tiers. If the river really formed this canyon, it would have carried all this material away. But it remained. Whole sections are blocked by boulders that the river is unable to move. This is not the product of current erosion. This is the cultural layer of an abandoned excavation. Dumps of waste rock that they didn't have time or didn't bother to take away. The Colorado River didn't create this canyon. It simply flowed along its bottom after the excavation was abandoned. It occupied the ready-made channel, the lowest point of the relief. It is not the cause, it is the consequence. The Grand Canyon is a planetary industrial quarry, an open-pit mine of an antediluvian Earth civilization. We live on the ruins, or more accurately, on the dumps. Look at the lone mountains and the steppes. They are the pillars of abandoned excavations. Look at the endless flat plains. They are cleared horizons. Ask yourself, why do we see, but not notice? Do not believe the textbooks, believe your eyes. The Earth is an exhausted mine, and anyone who understands this will never be able to look at the mountains with the same eyes again.